Hello everyone, and welcome to your video that starts introducing some tricks with proportions. Fred really likes this. He lays it all out for you on page 307, but I have found that unless we go through it slowly, everybody skips over page 307 and just hopes that they don't need that information. Well, you do need that information. So here's the first trick with proportions. It's called inverting. And inverting is just a fancy way of saying turn it upside down. And what inverting means is that, let's say you have this proportion. You have A over B equals C over D. What this means is that this can become, it's going to become B over A, so you just flip that upside down, equals D over C. So you just flipped both of them upside down. And I want to talk about this for a few minutes. The first question that you might have is, how can that possibly work? And the answer is the reason that it works is because you're doing the same thing to both sides of the equation. You flip this side, you flip this side. You flip this side, you flip this side. As long as you do it to both sides of the equation, then you're still good. So since you flipped this side, you flipped this side, everything is fine. Okay, let's put in some numbers and kind of play with this for a few minutes. So let's say that I tell you that we have 2 over 4, and that equals 5 over 10. First of all, you're not going to disagree with me, right? I mean, if you put in your calculator 2 divided by 4, you get 0.5. And if you put in 5 divided by 10, you get 0.5. And if you think about it for just a second, you will see that you agree with that. These are 1/2, right? 2 is half of 4, 5 is half of 10, so our decimal equivalent is going to be 0.5. Okay, that should make sense. So what this trick is telling us is that we can take these proportions and we can change them to say that it's 4 over 2 equals 10 over 5. Well, let's see. What is 4 divided by 2? That is 2. And what's 10 divided by 5? That is 2. Okay, so what I want you to notice is that we are not saying that 2/4 equals 4 over 2. We are not saying that. That would be wrong. That would be silly. That would be breaking all laws of mathematics. That's boo hiss. We are not saying that. What we are saying is that this relationship is true, and if you flip them over, you get another true relationship. Okay? If this relationship is true, and it is, 2/4 does in fact equal 5/10, you can invert both sides and get another true relationship. That is what we are saying here. We are not saying that these fractions are equal to each other. No, no, no. We are saying that this relationship, if true, can be manipulated in this way to make another new true relationship. Okay? So, if you have a proportion, you are able to invert both sides of the equal sign and come up with another true proportion. That's what we're saying. Okay? Let's try the second trick of proportions, which is cross multiplication. This one is my favorite, I have to say. Multiply. Having a little trouble with the spelling today. Cross multiplying. And what that means is that if we have A over B equals C over D, that means that I can cross multiply these two, and this becomes A times D equals B times C. Okay? Why does this work? I have no idea. I mean, I'm sure it's a very complicated proof that neither one of us really cares that much about. So we're not going to do the proof for it, but what we are going to say is that this is beautiful because it always works. Always. Isn't that a beautiful word? Always. It always works. Yes. And it is extremely helpful. Let's do an example. 10 over 2 equals 60 over 12. Okay, first let's prove to ourselves that this is a true statement. So you can get out your little calculator and you can put in 10 divided by 2 and you will get 5. And then you can put in your calculator 60 divided by 12 and you will get 5. Okay, so we agree that this is a true statement. Okay, so now what this particular trick tells us is that we can change this into another true statement, which is awesome. We can change it into 10 times 12, that's these two right here, equals 2 times 60. Or you could write it 60 by 2, it doesn't matter. And this is another true statement. And indeed, if you get out your calculators, 10 times 12 is 120, and 2 times 60 is 120. So again, we're not saying that 10 over 2 equals 120. No, we're not saying that. We're saying that if this is your proportion, 10 divided by 2 equals 60 divided by 12, you can manipulate it in this fashion and always get another true statement. Now you might be saying to yourself, great, but why in the world would we ever want to do that? I mean, how does going from one true statement to another true statement help us? Well, it does, and I'll tell you that this is very helpful when finding unknowns. So let's do an example. Let's say that we have 3 over x equals 16 over 24. Now, you might look at this and you might say, I can't figure that out in my head, and that makes math really hard, and now I'm going to whine about it a little bit. Yeah, that's one option. That's one way you could take it. But I'm going to suggest that we do something else. I'm going to suggest that we manipulate this proportion by using our cross multiplication into an equation that we can actually solve. So I'm going to say, all right, 3 times 24 equals 16x, 16 times x. And then I'm going to do this math. 3 times 24, that equals 72, equals 16x. Divide by 16, divide by 16, I get x equals 4.5. X equals 4.5. Now I know what x is. And just to prove it to you, that means that if I go back to my original equation, 3 over 4.5, that should equal the same thing as 16 over 24. Now, I'll warn you, it's an ugly number, but if you do it in your calculator, if you take 3 divided by 4.5, you get 0.6666666 forever. And if you take 16 divided by 24 and put that in your calculator, you get 0.6666666 forever. And so they do equal each other. So that's what we have proven, is that we took this information, we cross-multiplied so that we could solve for x, and now we have proven that that x does indeed give us an equal equation. It's very helpful, and we use it all the time. When Fred goes about solving a lot of his proportions and calculating the sides of similar triangles, he does it in such a goofy, convoluted, horrible way, when really all you have to do is cross-multiply and then solve for your variable. So I am a huge fan of cross-multiplying, and I encourage you to become fans of it as well. All right, so those are your first 2 tricks with proportions. There'll be another video that discusses others.